increasing until 8. Why 8? Because the capacity of your buffer is 8 pieces. So it will reach to the maximum number 8 and it stops. And then after 10 minutes, it reduced to 7 and immediately increased by 8, by 1. And so it means 8. Why 10 minutes? Because the processing time of the station is 10 minutes. So it means that you have 8 pieces in the buffer, and then after 10 minutes, you finish it, and then you send a new one to the station. So that's the reason why it reduced by 1 to 7. Then you have the supply you a new one immediately, and then that's the reason why they happen in the same moment. Okay, and again 20 and so on. Okay, so through this you know the behavior of your system. For example, if I change here a bit, so this is the should have the interval, so they will supply new MU for every 1 second. Okay, and then we run the simulation again. Open the time sequence. Sorry, to clear this one, you need to clear how to clear the time sequence. You need to clear the time sequence first. Okay. Really. Okay. Let's talk about. Yep, let's do it with the method. So this is maximum window vertical sequence. So what is the clear of the time sequence? I don't know, but I know how to get the correct syntax by open the time sequence. So what I'm doing now is first I need to delete the data here. Okay. Maybe you can simply just here and delete. Yeah, it's worked. But I want to delete here somehow automatically. How I do it? So if you want to do something, you open the method. The method again is the action, the behavior, the function that you want to do, and then you click on the object. You press F8. Okay, and then here they show attribute and method, and then hide the attribute and only show me the method, and I should add observe copy. There is delete. Yep, delete content. Maybe confirm the function by F1, and I read the information the method delete content, delete the content of the data table of this one. Yeah, this is the function that I want to have. Then here time sequence dot delete content. Okay, and then I just simply run this one. First F5 to save the method, and F7 to run the method, and then have a look back. Is it delete? Not yet. F7. This run. Home F7 to run the method, right? F5 to save, F7 to run the method. Yep. And then it should be, if nothing happens. Okay. So let me check. So how to run the method here? Right click, run. Nothing happened. So it's been not correct one. So F8 again. Set for delete, delete attribute, delete content, delete object. Should be the correct one. But why is not delete? Or just simply delete. Okay. F5 to save it. F7 to run. Yep, it's delete. Yep. Then now I run the simulation again and have a look on the time sequence. You see the different now in this case that at the time 0, I have the first MU go inside the buffer, and then also at the time 0, the buffer will release the MU to the station, and then they don't have the same point in time anymore, but every 1 minute I will increase the number of buffer or the number MU by 1 until I reach the capacity. And then after 10 minutes, when station finish processing the MU, it will take the new one from buffer. That's why the buffer now 7, and then have the new one from show 8, and then reduce to 7, 8, 8, and 7, and so on. Okay, so this is how you trace back the behavior of the system with the time sequence. Of course, you can track here the number of MU, but of course you can trace back a lot of data attributes that you want. Yeah, so as long as this attribute is in the list here in the attributes. Okay, but here the most common thing is the number of MU in the buffer. Okay, then step number 4, they said that in the buffer we have two buffer type, the queue and the stack. Okay, what is queue and what is stack? Here it means that first in, first out, you make a queue, the line. Stack it means first in, last out. You put the stack of paper, yeah, and then you take the paper on the top. Okay, so it means stack and buffer. Okay, and what is the difference between these two setup? If I put to stack now, apply OK, information flow in user interface here. Okay, 47. It's 47, and then you change here to queue. Okay, it's also 47. So what is the difference with stack and queue? Let me show the full summary report, and then you can see the difference. So this is first report, and this is for queue. Okay, then now I change it to stack, and then run the simulation again. Okay, put them side by side. This is simulation model. Okay, and then here So what is the difference? The throughput is the same. Both have 47 pieces, but the difference that you have here is the mean line time. On one side, that you have the 29 minutes, and then the other time, mean line time is 1 hour, 30 minutes, and 24 seconds, something. And then if you look in the value added, that you have here 34 percentage, and then here you have around 11%. Okay, so this is the difference that we can see from the data.
Why is the different?
Yeah, but the question is why? Correct. So this is a difference that we can see, but how we explain such kind of behavior? Okay, but first, what is mean line time? What is line time, and what is mean line time? Okay, line time of what?
Product, right?
No, this is a line time of the mobile unit of the MU. So, for example, let me make a sample. So let's do another frame.
Is it because of the stack, the unit that are always on the top that never been processed, so that's causing the lifetime is longer? Is it?
Yes, this is correct. But let me explain it in the full story. What is line time first? So if I have here and I run the simulation in how many hours? I forgot. 7 hours. Very faster. Okay. Sorry. The infinity. So it will never stop. This one, I need to put here 1 second at the same as this one. Okay. Then we run the simulation. And now you have the report. Now you have two lines. The first is the rain, and the second is the rain one, the one that I just created. And there's nothing. And then I just form the soup and then go directly to the rain one. And here you see the mean line time is 0. Okay, it means that it's clearly you can see that when it born in the soup one, it go directly to rain without doing anything. So it means that they don't live any second. They die immediately after they born in rain one. So that's the reason why the mean lifetime is 0. Okay, so if I have here a station, here 1 minute, 1 second. Okay, delete this one. Okay, it's been that 1 second go out, 1 second go in. Okay, and wait 1 second here, and then so the mean line time now should be 1 second. Yep, it's clear. So if I have, for example, the soup here, infinity soup, that means that takes 0 time. And then what happened when I click play? So they born in soup 1, they go to station 1, and there will be another one here. This is part, the second part created from soup 1. They not go directly to station 1. They wait inside soup 1 for how long? 1 second. This means that how long does it live in the whole process? 2 seconds. 1 second waiting inside SHUK1 and 1 second processing inside station 1. Okay, so it means that you have now the statistic value. So the pen you have MU line time. The first MU created in SHUK1 go directly to station 1 and directly go to RAN. Line time 1 second. The second MU 1 second waiting inside SHUK1 because the station 1 is occupied by the first MU. So he have to wait inside the SHUK1 and then spend another 1 second processing inside station 1. So the line time of the second one now become 2 seconds. And how about the third one? What do you think? 3 seconds?
2 seconds.
Also 2 seconds, correct? Because if the SHUK1 is occupied, no more, not no more, but no new MU is created. Yeah. So at the moment the second MU moves to station 1, and then the SHUK is free, then it can generate the new one and repeat the same behavior. So 2 seconds. And then what is the mean value if I have so how long I run the simulation? 1 hour, right? 1 hour. 1 hour is mean that how many seconds? 360 seconds. So 60 seconds is mean that we have in total 360 product, okay, or maybe only 359, okay, and then within 359 product, I have 1 times that the line time is 1 second plus 358 times the line time is 2 seconds and divided by 359, and then this is my mean line time. Okay, and let's see if that's correct. So mean line time here is 2 seconds. Okay. So I think that it's nearly 2, not actually 2. Okay, is it clear about the mean line time? Okay, then now move back to queue and start. Which one have the lower? First. Which one have the? So this is not relevant now. This is no, so not. This is not. This is the one. Yep, correct. Then what is the? So what do you think? The queue will have the low mean line time, or the stack will have the lower mean line time?
Should be the queue.
The queue will have the lower line time. Is anyone
Yes.
have a different idea, or you have the same idea? The same answer with your colleague? Okay, actually that the mean line time will be lower when we have the stack, not the mean. not the Q, sorry, Y. So here, so not this one, the other one. Yep. So here we have Q, and then here on the other hand we have stock. Okay. How many? What is the capacity? 8, right? You have 1, 2, 3, 4, 5, 6, 7, 8. This is the capacity of the buffer. The same with the stock from 1, 2, 3, 4, 5, 6, 7, 8. Okay, and they are full of MU. Okay, and what is the taken strategies of the Q? Okay, and here we have the same. The Q will have to take the first one, first in, first out, take the second one, take the third, and so on. So it means that you more or less have equal mean lifetime between 1 to 8. And then it's equal to some number. Okay. And then in the stack, okay, is the stack, you will take only the one, the first one. It will stay forever inside the buffer because they do it in stack, and the station only take one pieces per time. And what is the pieces that it take? It take the one on the top. It's mean that the first one is taken, they should fill in the first one, and then it take the first one again and again and again and again. So it means that you will have the lifetime of the first one more or less equal to the processing time inside the station, which is around 10 minutes. Okay, and because that you run the simulation in 1 hour, it means that you will have from 2 to 8 with the mean lifetime around 60 minutes or 7 pieces. Okay, and 60 minus 5, 7, so it means that it's around 53 have the mean lifetime of 10 minutes. Roughly. Yeah, so again, 53 times the mean the lifetime is 10 minutes plus 7, because just 2 to 8 will have the lifetime around 60 minutes, and then you divide it by 60, and this number is lower than you have the more or less distributed here. Questions? Of course, all of this actually that is need to be done in the production planning or manufacturing planning or operational research or production in general. Yeah, but here I know that you haven't did it yet, so maybe it's also good to talk about what is Q, what is stack, what is cycle time, processing time, mean time between failures, availability. All of that is just production definition, basic term and terminology in production. And of course, simulation is a good tool also for learning